Good evening. Today we are moving on with our last lecture, which was we finished at complete elicitation. We were talking about the process, and we did establish that elicitation and analysis will go for some time together, or you can say it will be progressively elaborated, because when we try to analyze, we will have to get back with some questions, and elicitation will happen again and further clarification will come out. Anyways, after this slide, we move on. How long will we keep doing that? This continues until the analysis produces no further questions. No more questions are there, and information is reduced to a depiction of the solution of the business problem, when we can figure out what this business problem would be. Can you assure me that we were here, or we did cover more?
Sorry, sir, can you please repeat your question?
Was this the slide we were on?
No, sir, I don't think so.
We did not cover it, no? Right. Okay. So what I was saying was that we will keep repeating the elicitation cycle until and unless there are no more questions to be asked, and the information is reduced to that level where we can clearly see a business solution, or when the risks of the problem emerging from the lack of complete information is considered to be acceptable. I feel that I have covered it. I don't know, but if you say that we have not covered it, I'll continue. I think we talked about the adaptive life cycle, and we did discuss some items here also. When we are talking about the yes, please.
Sir, I guess we have covered all this.
Yeah, exactly.
This is what I've been telling. We were on the topic 4.9.
Oh, yes. That's what I was confused about. Right. We are now at the right place now. Okay. So 4.9 was analyze requirement. We had completed the and elicitation. Elicitation was done. Elicitation was completed, and now we were on analyzing the data, analyzing those requirements, and we said there are 3 steps: analysis, define, thinking ahead about analysis, and what to analyze. One of the primary activities the business analyst perform is analysis, with much effort focused on requirements related information. So whatever we have collected so far, we are actually analyzing that, and this is the process of examining, breaking down, and synthesizing this information. And it entails looking closely at the parts of information, how they relate to one another. First, we have to establish a relationship, and then we have to look at it, how it will form a business solution. Analysis involves progressively and iteratively working through the information to lower levels of detail, and often entails abstracting to higher levels of details. We did discuss this slide also. Let me move on. I think we have covered this also.
Yes, sir, we have covered. Sorry, we were at 4.10.
4.10.
What we did, yes.
Okay, let me start from here. Okay, 4.10 is about model and refine the requirement. Yes, we were here, and I was telling you that there are so many models here, at least 18 different kinds of models which we are going to be discussing in various parts, the scope models and other types of models. We will be discussing all of these. So in this practice guide, the model refers to a visual representation of information. Whatever information we have collected, we have to put it in some form, in some chart or in some table, as if we can visualize, compare and get some results out of it. These visualizations can be abstract or specific, that operates under a set of guidelines. We already have certain kinds of models. So those guidelines we will use in order to efficiently arrange and convey a lot of information in a concise manner. We are trying to make some meaning out of that. The data we have received, we are now trying to synthesizing it, and through these models we will get some tangible results or something which can be visually represented. It is the simplest form. A business analysis model is a structured representation of information. Models may be diagrams, they could be tables, they could be structured text, whatever. And most of those things you already have experience in, and you will be helping me out on this as well. So there are several business analysis models and each serves one or more purpose. So you may be using more than one models in one of your projects, in your business analysis assignments, or you can select some out of them. So you can use one or more than one simultaneously, and you can pick and choose out of these various models. Examples of information related to business analysis that can be modeled include business objectives, requirements, business rules, and design. So the work of business analysis, the various stages you come across during business analysis, you can use some out of those models for doing various jobs. For fixing the objectives, you may have a choice of 2 or 3 models. For requirements, you may have a choice of few models, and so on and so forth. So continuously throughout business analysis, you will be using these models. So these models are helpful to find gap in information. Where you do not have enough information, you may go back and elicit more information about it, and to identify extraneous information which is otherwise missing. Models provide context to better understand and more clearly convey the information. Requirements are modeled and refined to achieve further clarity, correctness, and to elicit additional information to define the details necessary for the product to be built. So what we are trying to do is, we are trying to get to the solution, and for that purpose, till we get to the solution, till it is easier for us to conceive the solution, we will keep using this exercise of using different models and doing this analysis. When the correct models are applied, analysis becomes simple relative to analyzing the information in pure text form. You have got a lot of data. Maybe you have got millions of forms to interpret. How can you get any results out of it until and unless you get the data out, put it into some table or some computer or some analysis tool, and then see the results, and from that result you will be able to make certain deductions. Because the models have helped visualize and summarize complex information, when the correct models are applied, analysis becomes much easier. Categories of analysis models. Analysis models are organized into specific categories defined mostly by the primary subject matter represented. One categorization of models is shown in the next table, which I'll just be showing you. So these are some of the models, and we will be discussing. These are the 18 example models. I'm not saying that these are the only 18 models, but all of these models are some of the possible examples of these models which you could use. There is very much a possibility that you can have many more models. So we have got certain models to deal with scope. We are trying to establish scope. So scope models, these various models are meant for that. And some of those models you might already know, you might already be aware about, like fishbone, SWOT analysis, and lot many things you might have already known and understood. But we will be using these. These models structure and organize features, functions, and boundaries of the business domain being analyzed. So it is more akin to the requirements. Then our process models, we have here three models as example: process flows, use cases, and use stories. These are the models which describe business processes and ways in which stakeholders interact with those processes. You know how the things happen. A process flow will tell you what information gets into what process and how it is processed, and ultimately what comes out of it, and then what happens. So the complete flow of information through various processes and through a complete system can be traced through these process flows. So whatever information you have collected, you will actually develop the process flows out of them. After having ascertained the requirements correctly through the scope models, then you will develop the scope process model, for which you can use naturally process flows can be used, which is a very important, usually used technique. Then use cases and use stories can also be used for that purpose. Then there are rule models. Rule models are establishing rules. These are for concepts and behaviors that define or constrain aspects of business in order to enforce established business policies. So these are the rules, policies which you apply and say whatever requirements come within that sphere, within the rule model. These different rules are, the examples of these models are like, business rule catalog, a decision tree, or a decision table. Then we have got data models. These are the models that document the data used in a process or system and its life cycle. We have got entity relationship diagrams. We have got data flow diagrams. We have got data dictionaries, state tables, state diagrams. I'm sure you must be aware of most of them. Lastly, we have got interface models. These assist us in understanding the specific systems and the relationship within the solution. And we have got a report table, system interface table, user interface flow, wireframes, and display action responses. Some of these models we have already discussed in the previous slides also, but anyways, these models will be used for analysis purposes now. Previously, if we used any of these models, that was for the purpose of elicitation. Now we are going to be using them for wireframing, for analysis purposes. Okay. So choosing the correct model can be difficult because often there are multiple valid choices. You can have, say you have three models for doing something. Which model should you use? Naturally, you are the best judge, and moreover, the type of work you are trying to do, you would know which model is most appropriate for that. It is unlikely that all of the models will be used on one project, but for most projects, more than one type of models will be used, as I explained earlier. In some cases, there are many models that could be applied, but time constraint may require the business analyst to choose only a few of them. So, yes, it is a possibility that you may use more than one model, but again, if you don't have time, then you will not be going for that. You will, restrict yourself to the most appropriate models. In these scenarios, models need to be prioritized according to the applicability. So you would say that this is the most important model and I'll be using this. The business analyst should consider the following when choosing these models. So how do you choose these models? You must look at the methodology you are using, characteristics of the project, timing within the project lifecycle, how much time is available to you, what are the various categories of models available to you, and what is the level of abstraction, how much in detail do you want to go. Methodology tells us the choice of models or formality, and depth of models can be methodology independent. However, certain models are more suited to one methodology than another. So maybe you can use that, right? It says user stories here, but if you are, working on uh, agile systems, then you probably would be going for the user stories there, as it is used in agile. It might be slightly different. Characteristics. Project characteristics such as business process, automation, custom development, commercial off-the-shelf, lot many, whatever type of project you are doing, that will dictate what model suits it best. Timing, as we have already discussed, some models have a lot of time, some models have less time. So whichever, how much time is available to you and what kind of life cycle you are adopting, that will also govern which life cycle you have to take. Categories of models from every category, as you have seen in this table, they all apply, and we can use whichever model is more suitable to us, and which are the categories available to us under the work I want to do. Level of abstraction. Models represent different abstraction levels. Some are better suited for analyzing a whole solution, others for elements of a solution. So choose that which is more appropriate for your purpose. For example, as I was saying, in an agile project, we like to use user stories as opposed to use cases. This was the point I was trying to make, that then you use user stories, not use cases. But if you are not using agile, then probably in IT and software development, we normally use cases. A reporting or analytics project will likely use data models, including a data dictionary and report tables. So in that scenario, you would be going for these kind of models. System migration project will probably have scope models such as an ecosystem map or a context diagram, as well as data models like data dictionary and a business rule catalog. So that all depends upon what kind of job you are taking. Early in a project, business analysts usually create context diagrams, ecosystems, maps, and high-level process flows. Later in a project, business analysts may create state models, decision models, and user interfaces. So you see, as we move on with our work, the level of abstraction will define, the time of the project lifecycle will define which tools are to be used at that level. A project that involves automating operating functions benefits from process models to elicit information about how work is currently conducted and how work will be performed after the automation is implemented. It is also helpful to use more than one model, as we said earlier, because the models complement one another. Maybe you have to get a result of one model and put it as an input into another model for further results. So, and it will enable analysis of the project from different perspectives. For example, a data dictionary describes attributes of the business data objects, and thus data objects are also reflected in entity relationship diagram. So the same data items are put into the entity relationship diagram. The allowed transitions on a state diagram are reflected in one or more of the process models. Cross-checking models against each other will help find gaps, unnecessary information, and potentially missing requirements. So it is your choice. Business analysts use models to determine what is important and valuable so that right requirements are created. Models are used during elicitation sessions to refine requirements. So we did use it during elicitation, as I was saying earlier, we did use some of those models in elicitation also, and we have already discussed them. But some models will be used again and some new model will be used now in analysis. Though through an iterative process, it means we will keep using some models iteratively. The details become sharper and sharper until there is clear picture as to what is important and what is not. Each model explained from here onwards would be covered under headings 4.10.7 to 11. 7, like 7 would be talking about the scope models and so on and so forth. All 5 types of models will be discussed, and in each type there will be several models, each one of the one we already explained. Then we have got modeling languages. There are many modeling languages and each has its own strength and weakness. Some common modeling languages are listed here, like you must be knowing even better than me. We have got business process modeling notation, BPMN. It is used to model complex business processes for the purpose of making changes to those processes. Like we probably will use it when we are trying to improve our system or re-engineer a system. Requirements modeling language is called RML and is used to visually model requirements for easy consumption by the stakeholders. And these stakeholders, if you can start explaining these requirements to them, they may not understand the language and it would be too lengthy. We are trying to put it in form of a table and then showing them. That would make it more understandable for them and will take less time. System modeling languages, these are to analyze complex systems and indicate a subset of UML. UML is Unified Modeling Language, which is very commonly used and you must be using it already. They're primarily used to specify design models but can work well to specify requirements. And there are various other modeling languages. Naturally, all of them could not be listed here. They are used when a specific modeling language isn't appropriate or not part of the organization standard. So your organization may specify which modeling language they want to use or which is more suitable for you. Like, data models often use information engineering crowfeet notation, which we will be talking later as well. Whether a specific modeling standard is used during analysis or not, it is not unimportant. What is important is to use consistent syntax for each similar model so as not to confuse the stakeholders. So whatever terminology or lingo you are using or notation you are using, you try to use such models which use consistently the same notation. For example, when creating process flows, use the same shapes to mean the same things. If it is a box for a process, then it is a box for process. Always use a box for process, not a circle. In addition, it is helpful to keep the model as simple as possible. It is difficult for stakeholders to read and understand models that contain overly complex syntax and information. So if you have to deal with and interact with the stakeholder and show them these models, please do not show them those models which are too complex to understand, because we know you being a business analyst, for your own analysis, you may use those models and you may understand those models better, but for stakeholder, make their lives easier and show them easier results. Ji, please. Ji Adil. जी अदिल, आप कुछ कहना चाह रहे थे? ओके, जी जी बोलिए.
All right. So one thing which I'm getting confused right now is why we are using these models.
As explained earlier, these various models are for various purposes. If I can go back to that slide, we have got purposes are explained here in this slide. Let this slide come to you. So this is why we are using these things. The purpose is written in the definition. We have got 5 types of models. Scope models are to structure and organize the function feature. So when we are collecting the requirements, when we are collecting,
sir,
yes.
All right, sir, I rephrase my question. I understand that these are the models, and this is the definition of these models, how it is used and when it is used. But my question is that at this point of time, we have illustrated all the requirements and everything.
Right.
We have reiterated our elicitation requirements and everything. So now, why we are putting it into the model?
Okay. The confusion here is that you assume that we have done that. I say we have not done that completely. We have collected the information. We are using these models, and you remember we were using these models when we were eliciting the information also. Some of the models were elicitation models. We were using those models, but and we were confirming it from through feedback also. And But when we get more into analysis, then we again use these models, some more questions come out, some gaps come out, some extraneous information comes out, and I get back. So this is part of the ending the elicitation. Elicitation is altogether not ended. We are still discussing the closing of the elicitation, and in this process we are going through the analysis of the requirements. So because I said
Okay, sir, I got your point.
it is iterative in nature, so we are getting back to those things. We'll keep doing that until and unless we have everything clarified. Okay. Okay. So I was saying that for 7 to 11, 4.10.7 to 11, we'll be discussing these models. Each model description includes an overview. This is a pattern how we'll be discussing it. Each model will give an overview, its syntax. There would be an example and its usage and relation to the requirements. Now this is some information. All these models, this is something you can't remember. You have to keep it handy for reference until and unless you are very experienced and you remember everything by heart. So you can always refer back to these models and even more models which are not given here. But this is a very good way of representation that they have given it a format. All these models are being given a specific format. So this is easier to read and understand. Moreover, you may have better knowledge and information about these things, and you may even know more. So how is it represented? An example would be given. The examples for the models are based on a mock project, and let's call it a recipe box for the grocery chain. So this is a mock project. This is not a real project, it's a mock project, and we would be referring to that. This is a mobile application project that allows users to select various recipes, look up grocery stores that have the ingredients, and then map the location of the ingredient in the store. A new recipe is sent daily by email to participating customers. Ingredients for the recipe are on sale at each of the grocery stores. You understand how we are doing it? We have developed this mobile application. As soon as a new recipe is floated, all the ingredients of that recipe would be available on sale. So this is understanding we have developed with that grocery store, and that's how we will promote our recipes, and naturally that grocery store will sell those items. Ingredients for the recipes are on sale at each of the grocery stores we have mentioned. Customers can use a mobile device to run the recipe box application to display the current and past recipes. The application also shows the location of the items for the recipe at the store selected by the customer. Exact location in the shelves where that recipe is lying. So you could straight away target that, and you can go to that store, pick that item, get it on sale, and go get home and develop that recipe. Anyways, this is the example we will be taking on, and that example we will be applying to these various models. We have got 5 different models for scope. We have 3 different models for process models, 2 for rule models, 4 data models, and 4 interface models. We have total of 18 models to discuss here. So let us discuss first the scope models. We have got, in general, scope models are used to structure and organize the goals and objectives, features and functions and boundaries of the business domain being analyzed, and this was a definition we did study when we were looking at that table where all the models were listed. So what are these models? First of all, goal model and business objective model. So goals and objectives will be addressed through this model. Ecosystem map, context diagrams, you must be very well aware of. Feature models, again, you must be knowing that. Use case diagrams also. So let us start with the very first model, and that is a goal and business objective model. Goal models and business objective models are diagrams for organizing and reflecting goals, business problems, business objectives, success metrics, and high-level features. So all this data we collect from the stakeholders would be organized into this specific goal model or business objective model. Chains of business problems and business objectives easily show where the project value comes from. Whether the value is identified as increasing revenue, decreasing cost, or avoiding penalties, goal models and business objective model visually represent the value that supports feature prioritization decisions and product scope management. Let us have a look at that. The collaboration point here is the project manager may be able to help complete portions of the goals and business objectives. For example, when the project manager has already developed a cost benefit analysis or business case, some of the information needed in this model may already exist. So I already have a fair idea what my goals and objectives are. This is the diagram which shows the goal model or business objective model. In this you can see BP1 is profit per visit is down. This is our first problem. So what we do, the business objective would be increase the profit. Business problem was profit per visit is down, and business objective is increase the profit how much? Per visit by $3. Now what is the business problem in that? Consumers purchasing low margin frozen meals. So what is the objective then? Increase the sales of higher margin cooking ingredients by $10 per visit. So what we can, you see, we cannot, people are purchasing the low margin frozen meals, and higher margin cooking ingredients are not targeted. So if higher margin cooking ingredients the cost is increased $10 per visit, if we can earn out of that, then we will be able to achieve this target. But again, there are two problems coming out of this business objective, and that is, first problem is consumers are reluctant to cook because shopping lists for recipes are time consuming. That is another problem which is causing a hurdle. So to solve that, my business objective is enable customers to create recipes shopping lists in 15 seconds or less, make their lives easier, and ultimately the solution comes out to be the feature we want to add would be recipe management. So we will have a database created for the recipes, and easy access will be provided to the consumer, and that consumer will be able to give us more money by buying those high margin cooking items, because we are not targeting the low margin cooking items because that are a business problem. So we have diversified. Coming over to the other leg, the business problem 4 is locating ingredients in store is a hassle. So what is the solution, or what is the objective? I want to enable the consumer to locate any item within 1 minute on his mobile. How do we do that? Number one, I provide a store guide online on his mobile and provide him a mobile access. Currently, how many items are lying and where they are lying. So I will show that on a map, and I will provide him the mobile access, online mobile access, and therefore from the data I have collected, I can clearly understand what are the requirements of the recipe box project. I want a recipe management system, I want a store guide, and I want mobile access, online access available to the consumer. If I can provide these things, I can make the recipe work. So no matter if this is complete or not, this is just the first step. This is just one model I have used, and this model has already helped me in coming to a conclusion. You see, if you have never used this model before, you will understand it is not that difficult to adopt. With one or two iterations of your problem and objective, you can very quickly start and conveniently start using this model. Any questions so far?
No, sir. So far, so good.
Have you used this model before?
No, sir.
Okay. So you see, whatever models you use, before starting using them, if probably you can use this for, fixing your features, understanding your features, that would be a great convenience. So the figure I have just shown you, figure 4.2, it shows one form of business objectives model for the recipe box project. In this example, the high level features trace back to the overarching business problem that is being addressed. Profit per visit is down, so we are addressing that. The measurable business objective is to increase the profit per visit by $3, and as we have discussed, we had a problem. We could not go for it due to people are going for low order items which are on sale. To increase the profit per visit, the grocery chain wants to increase the sales of items. Recipe box product includes the features that increase the consumer desire to purchase such items and also make it easier for them to locate and purchase them. Okay, if we have understood the problem and example, let us see the usage of this model. Although commonly constructed during the planning phase, a goal model or business objective model can be created at any time during the project. You see, this we did it when we started the thing. We did not have any other thing. We did not use any other model. So we could start from here. But during my business analysis, at any stage, whenever I feel that there is a new feature required, I can again build this model for that specific feature. It is not necessary that whole of this diagram should, match. But anyways, if we can use the same diagram and improve upon it, we can identify more features. It may be helpful to create the model as soon as possible. Naturally, this should be done as early as possible. The very first thing you should do is to create this model so that teams and business owners can start assigning the numbers to the features they are attempting to develop for a particular product. It can be used to justify budget as well as to reveal to executives exactly what they are receiving from a project. So their expectations can be set. We can have a fairly good idea what we are talking about and how much money can be spent. I'm not saying that come up with a detailed estimate, but if you say I have to create a recipe system, I have to create a online system or something like that, we already have experience with those projects and we know how much it may cost. When some business objectives are mapped to the requirements, scope control becomes much easier as a particular value of the specific requirement is better understood. Now, what is the relationship to the requirement? These models provide a structure to specify business requirements. It is a structured approach. Each functional requirement produced for a project should be traceable to the identified business problem and objective. So you can very easily trace back every feature to the requisite business problems and objectives. Maintaining a focus on the top level business problem and business objectives guide the delivery of valuable solutions and shapes the scope of the features. The value of requirements or features can be quantified based on how these requirements contribute to the business objective in the model. This helps to identify the most important feature to implement or identify the minimally marketable features, MMF. MMF is minimally marketable features. So these are the features we have identified which should at minimum be provided in our system. These are doable. These are marketable features. I am not saying this is a complete list of features. I am saying this is a minimally marketable feature. So you may
Sir,
yes,
sir, sir, I was not able to hear you on slide 1.
example or usage.
Sir, relationship to requirement.
Okay, relationship to the requirement. Okay. I was saying uh, these models provide a structure to you. In nutshell, what I should say is that although they do not give you all the features, but if it gives you the basic features connected with the business objectives and the business problem, you can trace back. You can travel back from your features and see which was the business objective we are satisfying and what was the business problem. You can trace it back. So it can be done in the very beginning, and it will, I'm not saying that this is the complete list of all the features to be available in your system or project, but I'm saying that these are the bare minimum, bare essential features which you must have in your system. So these are called minimally marketable features. Minimally marketable features. That is a bare minimum you want to have in your software. And they are doable, they are marketable, they can be sold, and there is a market for them. So these features are my capital features. These are my most important features. I may have several other features added to this list, but the priority goes to the MMFs, minimally marketable features. Do you get it?
Yes, sir, I get it.
Okay. And these models provide a structure. This we have already discussed. Next is ecosystem map. An ecosystem map is a diagram that shows all the relevant systems, the relationship between them, and optionally any data objects passed between them. So it focuses on the various systems which are existing. And if there is any interaction between them, any movement of data from one system to the other, that can also be shown. The systems are logical systems and therefore they may not match an actual architecture diagram of a physical system. This is hypothetical. This is not exactly how the things are actually connected on ground. An ecosystem map is made up of boxes representing the systems and lines between the boxes that depict the relationship. When data is shown in diagram, the labels on the lines identify the data objects and the arrows show the direction and flow of the data flow. So just look at it. This is the ecosystem. Let us see the various systems we have got. There is a customer email system, there is a loyalty program system, there is a mobile application, there is a shelf layout, there is a print ad layout, there is a store inventory, there is inventory purchasing, barcode scanning and checking out. These are, we have identified that these are the various points of various systems which have to interact with each other. So we have to create a relationship amongst them. How do they interact with each other? For example, customer email and loyalty program. There is a relationship. Customer purchasing history must go to the loyalty program, as if loyalty program can send promotions to the customer email. So we do have a customer email, and if we have been interacting with this customer, then probably he's an old customer. Old customers data should go to loyalty program, and loyalty program should start sending them new promotions. And these promotions should be sent through the mobile application, right? Okay. So what else? Mobile application will also get data from the print ads. So latest ads should be displayable on the mobile phones. The shelf layout, that is the layout of the store, this is coming from the shelf layout system, and it should also be available in your mobile. Okay, how the shelf layout is affected? It is affected by the availability of inventory. The items are there in store or not, and where the items are coming from, they are coming from the store. The store inventory will tell us how many items are lying in the shelf, and print ad will tell me the availability of the inventory and any upcoming promotion. If there is a new upcoming promotion, store inventory will catch up and fill in more stuff and ultimately make that inventory available on the shelves. So this is a very intricate system we have to develop. And store inventory, as soon as they run low on the inventory, the items, they are lacking those items which are about to be sold, they should immediately send in a low inventory product report to the inventory purchasing, as if the inventory purchasing system can be invoked. And how the inventory would note what is happening? As soon as the product ID comes from the barcode reader, inventory store deducts that item from the list. That they had 10 items, one has gone. So one has gone, therefore one item has to be filled into the shelf layout. And because we are short of one, we should maybe send in a purchase order for that one item. They do not order for one single item. Normally they have got maybe a box of 12 or something like that. Only a predefined amount is ordered. So available inventory will go to the barcode reader, and that barcode reader will help us check out. So checkout is giving me the inventory update. It is giving the receipt to the customer, and this cycle continues. This is the ecosystem. This is how your system is going to run, right? So I am not saying that it is easy to develop, but at least you have a mechanism. You can start playing with this ecosystem map. You can start creating your own ecosystem map based on how this is made. And I hope with one or two tries, you will be proficient in doing this. So if we fit in, yes, please.
So basically, we are using ecosystem map for our to show how all the systems are integrating with each other.
Okay,
so, but it has been named in a different format. It's being yes, we used to call it as an architecture diagram. System architecture diagram.
But
so
if you look at the definition, it clearly says somewhere that these are not the architectural diagrams. Architectural diagrams are more intricate in nature. I just read it here.
It's in the first paragraph, last line.
Yeah.
An actual architecture diagram may not match an actual diagram. Sir, it says it may not match.
Right.
But if it is matching, so it can be.
It can be, but architectural diagram is more intimate. It is more detailed. This is sketchy. These are just boxes, the thing going here, from there to there. But in architectural diagram, things are to some scale. In ecosystem map, things are not to any scale.
So I've used the word system architecture diagram. So what I personally feel that all the systems are mentioned in that diagram.
Okay.
So if we take mobile app is one system, loyalty program is one system, customer email is one system. So all the systems are talking to each other.
Exactly. So this is one and the same thing. There are a lot many examples of various models you can take up which are not mentioned here, and they might be alike. They might be used for the same purpose. So in your organization, you may be using another type of model, but that we just want to show here that this is one of the models. It is not mandatory. It is something you can use, or you can have another name for this. What is the usage? An ecosystem map is used to understand all of the systems, how they behave, and that can be affected by or that will impact the in-scope systems. It is a good model to represent systems that are in scope early in the project. So again, as soon as we can go on for creating this model, the better it is. In particular, the model is used to determine where there are possible interface requirements or data requirements, where what data is coming from where to where. This model is slightly different than a context diagram. We will talk about the context diagram because ecosystem diagrams may include interfaces and systems that the solution under analysis does not interact with directly, right? So context diagram doesn't have that. So here we can have those systems which are not even our systems, even the market or something, ad agency or something like that. Those systems are not our systems, and maybe we put them as a box here. For example, when a mobile application is being developed and there is a shelf layout system that directly interacts with the mobile application, both systems should appear in an ecosystem map and a context diagram. However, there could be an inventory system that does not interface with the mobile application. The inventory system of the store could be a different system. It does not interact with the mobile application, but does interface with a shelf layout system. So we must understand that those systems which are not part of our mobile application are still interacting with us. In this case, a business analyst may decide to show the inventory system in an ecosystem map so the audience understands the source for the inventory data that the shelf system is using. A context diagram would not show the inventory system because it does not directly interface with the mobile application. Using the ecosystem map, a business analyst considers how the system relate and sees interactions that may otherwise have been overlooked. We'll talk about the context diagrams a little later in the next time, next model. Okay, what is the relationship to the requirement here? The ecosystem map is a high-level representation. It is not a very detailed representation. It is a high-level representation of the system interfaces, but does not contain specific requirements about these interfaces. System interface table should be completed for each of the interface identified in an ecosystem map. So whatever we have identified as an interface, that should be included in system interface. And system interface we'll talk later. These are the system interfaces, and these will be discussed at the end. Data models also should be created to define data requirements for each of the data objects passed between the system. So this system, ecosystem map, is actually giving birth to the use of many other systems which will come later and which are more detailed for the analysis. Coming over to the context diagram, it shows all the direct systems and human interfaces to the systems within a solution. The diagram shows the in-scope system or systems and any inputs or outputs including the system or actors providing or receiving them. Number one, it is not only talking about the systems, it is also talking about the actors. Systems and actors, their interaction. Number two, it is only talking about the in-scope systems and it is not talking about other systems like we had in the previous case. The context diagram typically shows the system under development in the center of a circle. So the methodology used here is that the system we want to develop is to be shown in the center and other things are shown around it. Interfacing systems as boxes, human actors as people shapes are boxes and lines connecting them to show the actual interfaces and the data passed between them. And this description of how you should depict the boxes or lines, this might not be exactly the way you use it. It may be, you don't use boxes, you use circles or you use triangles. It doesn't matter. But you must have a consistent policy of using whatever convention or notation you are using. Context diagrams are sometimes referred to as level 0 of our data flow diagram. They grow into a data flow diagram, but this is the very basic level of the data flow diagram, which we will be discussing later. This is how it may look like. So the mobile application we are trying to develop is shown in center in a circle. All other in-scope systems which interact with the mobile application are shown as boxes around it. So with mobile application, what all in-scope systems are interacting, we have got a loyalty program interacting with it, sending the promotions. The grocery shop, how are we dealing with it? We are sending the product availability, receiving the store selection, receiving the recipes, receiving the user credentials. This is all coming from the grocery shopper. The grocery shopper, we are sending him the product location in the selected store. So these all items are interactions or objects are to be with the grocery shopper. Print ad layout is a weekly ad which is being given to the mobile application. GPS system is the mobile application is asking the location, and GPS system is giving the location of the local stores or the exact location within the local store. Shelf layout is giving us the store layout and the items location where exactly the items are lying. So this is a context diagram for the same example. So this displays the interaction between the mobile application system being developed and the external entities which are in scope. It is similar to the ecosystem map in concept because it illustrates data transfer or interactions between the system, but it includes more entities than just systems, such as the grocery shopper. Now, grocery shopper, he could have shown it not like a box, but like a man or a figure of a person. So it is very much possible, and it is good that if you can somehow differentiate between the systems and the people, and if it only includes entities that directly interact with the system being developed. For example, the inventory system sends information to the shelf layout system. Both, and that is not included. Inventory system is not included here, but it does send the shelf layout, send data to information to the shelf layout system. Both systems are included in the ecosystem map, but only the shelf layout system is in the context diagram as it has a direct connection. Indirect connections are not allowed here. Usage would be, the context diagrams are particularly useful early in a project to specify the scope of the project, including any interfaces that have to be developed. I think if you had this ecosystem map and then you develop the context diagram, the things will be much more easier. You can always refer back to ecosystem map and see what other interactions exist, but here the direct interactions are shown only. It also shows all of the external touch points between the system under development and other systems or people. These are the direct connections we are talking about. Context diagrams are also helpful in determining where there could be interface requirements or data requirements. Context diagrams may begin to be used by business analysts more broadly to model their business, users, data context. So for various purposes, you have to get back to the context diagram because context diagrams are easy to build and understand. Context diagrams can also model the as is and to be states in order to help with gap analysis. So I can create a context diagram of a as is system. I can build another context diagram of to B system and then compare these two and see what changes I have to bring in the existing system. Relationship to the requirements. Context diagrams do not specify requirements but summarize the product scope and related information that are analyzed to identify requirements. Because context diagrams are used to specify all of the interfaces, these diagrams can help identify when interface requirements need to be elicited. For example, system and human interface requirements will have to be identified there. This model often leads a business analyst to create system interface tables, user interface flows, display action response models, or other interface models that help to specify interface requirements. So this is a good input for various other interface models and data models as it is going to be used there. Feature model. Feature model is a visual representation of all of the features of a solution arranged in a tree form or a hierarchical structure. This structure could be, built horizontally or vertically. That does not matter. A feature is a group of related requirements described in a few words. Most projects have features at varying levels. That's why we are using the tree format. So these top level features could be the level 1 features, L1 features, followed by L2 features, which could be represented as 1.1, 1.2, L2, sorry, and so on. Most featured models with have 3 or fewer levels. Do not try to make 10 levels. 1, 2, 3 is okay, but not more than that. A given branch of the feature model always has a feature at the end of it. So we always have the last at the lowest level, whatever is the lowest level, L1, L2 or L3, we will have a specific feature and it would be connected to the main tree through the branches of L1, L2, whatever. So let us see the feature diagram, feature model here. So what are the features you are providing to the mobile shopper for various purposes? For loyalty, we have the loyalty points, the discounts, the referrals, and the specials, and these will give us the feature of loyalty. For providing him the listing, we must provide him various features. Sorry, loyalty is not a feature. Loyalty is something we want to have, and the features would be points, discounts, referrals, and specials. So, as regarding to the list, what all we have to provide, what all features, he should have a search facility, he should have a wish list option, he should have a favorites tag. He should be able to verify the list from stock. He could delete the item. He could see the history. He could add something to the list. And you see, the features shown in black are the most important features. Providing a guide. What all we have two branches. One is the branch of map and the other is the location. In the branch of map, we have list overlays and recipe overlays. So these two items, the location and the recipe items available in that location must be shown together. As far as the location is concerned, we have the zip code and indicate the my store. So we should be able to help the grocery shopper, the mobile shopper, to find the store nearest to him. So these gray items are what the features actually are. Card, he should be able to delete the card, send the card online order, change the quantity, add to the card, things like that. For recipe, we have got three major features: create, search, and daily special. So in create, we should be able to enter the data or we should be able to import the data. In search, we can search the history, we can search the popular, we can search the categories, cost and main ingredients, and daily specials could be directly, coming as notifications and promotions to the mobile shopper. So in this diagram, it demonstrates features for a simple recipe box solution. Feature model shows 5 L1 features such as list, recipe and guide. So list, recipe and guide. These are L1 features. Can you see my cursor?
Yes, sir, I can see your cursor.
List, guide and recipe. These are L1 features. With the respective L2 features, for a few of the L2 features, there are L3 features. So these are the L3 features which are on the next level. For example, list, recipe and guide are included in the current iteration, and the rest, the feature in light gray, are for future iterations. Immediately, we should focus on the main feature. Later on, although we will provide all the other features also, but they will be, designed later. They will be included later. But for the time being, we should have these features included. Feature model can be embellished using colors or patterns to indicate scope. Like, we used here the dark black color and gray color. You could have used different colors or patterns to indicate the scope. For example, one color should show could be used to show what is in scope for the current release, and another color could show what is out of scope. Usage of this model is, feature models are helpful to show how features are grouped together and which features are sub-features of other ones. Feature models are useful because they can easily display up to 200 features across different levels on a single page, which may represent an entire solutions feature set. So in this model, in a very tight space, we can show a lot of data. How is it related to the requirements? Feature models usually do not show requirements, but rather set of requirements. Features may have a number of requirements. So feature has been identified here. So this is the connection with the requirement, although the requirements are not explicitly shown here. Feature models help to determine how to organize requirements for business analysis. Efforts are layout features in a requirements document. Features found within a feature model may also be used to trace requirements to ensure that no features or requirements are forgotten. So we can always come back to this feature model and see and track if any feature has been left out. If it is, then we can always add it at any stage. Fifth are the use case diagrams. A use case diagram shows all of the in-scope use cases for a system. In a use case diagram, a use case is represented by an oval with the name of the use case within it as shown in figure, which I'll be showing you just now.
Sir?
Yes?
Sir, I'm good with use case diagram.
However, can we skip that?
Yes, sir.
Okay, good. So these are the use cases, these are actors, and those are, Okay, then move on to the process models. Again, process flow is very common. You must be aware of that. Let us see. Process flows also are called swim lane diagrams. Process maps भी कहते हैं, process diagram भी कहते हैं, process flow chart, whatever you want to call it. They visually depict the tasks that people perform in their jobs. Typically, process flow describe the steps that people take, although they may describe system steps and could be called system flows. So process flows could be called system flows in some cases. In process flows, boxes depict steps, diamonds indicate logic, and arrows show order of flow. Process flows may also contain swim lanes, which group steps together that are performed by the same person, group of people, or system. It is helpful to describe only people or system process steps in a given diagram to reduce shifting the context for the reader between the human and system processes. So I can create a process flow only for humans and another process flow for systems, because then we will have minimal number of swim lanes. Process flow.
Sir,
Yes, yes.
so basically, the presentation you have shared, in that presentation, these slides are empty. I'm referring to slide number 156.
You can download it right now. These are available there. I updated it on the OneDrive. If you can quickly download it, then
Okay.
we can move on. But it is.
Got it, sir. We can continue. I can see your screen, so we can continue on this. Later on, I will download it.
Okay, okay. Again, it says the process flows are developed to model as is and to be systems. The example here is, it shows the process flow for creating and sending the daily recipe for the recipe box application. Process flow has two swim lanes. You see, two swim lanes. One, let us see it here. Is it okay? Let it be visible to you. Still cannot see it. No, now you can. Okay. Now look at this. It shows two lanes. One is for store representative and other is for customer. As I said, it is good that if you can show these process flows between humans separately and between systems separately. But there is no barrier that you can't do it otherwise. But the whole flow should be shown. So what are the responsibilities of store representative, or what are the interactions of store representative would be shown in front of this lane. The other lane is for the customer. So all actions taken by the customer are shown here. So let us start from the store representative. He creates a new recipe, then he stores new recipe data. It is put into the archive, email new recipe to the customer, and that is now reaching, new recipe is reaching here to the customer. If he likes it, he selects it. If he doesn't like it, he selects the recipe from the history. And ultimately, in both the cases, he might find a recipe, and that recipe could be sent back to the system display store map with ingredients. Now, what it has done is, the system display store is a system, and this system relates to the store representative. So although there is no direct link with it, but it is the responsibility of the store representative, therefore it is shown. One link we have missed is that after the new recipe has been uploaded, the data is available, it informs stores of the products to be put on sale, as if they can do that. So the email, when it goes out, the stores have already been informed. So the usage here for the process flow.
Sir, which link is missing? As per my understanding, all the links are appropriately mentioned.
Mm-hmm.
Can you please go to the diagram? Backside?
Yes.
So which link is missing? You have mentioned me that there is one link is missing.
one link is missing. From where to where?
So you have just said that there is one link is missing.
No, it is not missing. I missed talking about the informed stores of
Okay.
products to put on sale, because
Okay. Yes.
there are two lines. One line is going to email, one coming to the informed store, and then they are both being communicated to the customer. So the usage here is process flows are valuable on most types of projects where there are people performing the tasks in the solution. Process flows are particularly useful for facilitating conversations during elicitation with business stakeholders, because process flows are intuitive to create and read. If you create this process flow and show it to your stakeholder and explain it to him and then ask for clarification, he would be able to understand very quickly, and he would say, no, this link doesn't go here. This link has to go somewhere else. So he can correct us. So that is the reason why we are going back to the stakeholder time and again. During analysis, process flows are used to identify missing features or requirements by tracking requirements to individual steps within the process flow. So we will keep revisiting the process flow, we'll keep adding new lines and new connections, and that way it will keep improving. Process flows can be drafted ahead of time or created real time during the session. If your stakeholder is well educated about these things, you can do it online and show it on a slide projector, or you can show it on his screen right away, and you can keep making it and showing it, and you may be amending it on the go. That will save a lot of time. They are an easy model for business stakeholder to review as part of the requirement verification. Process flows can be used to discuss as-is processes for current solution and future processes for new solutions to identify changes or gaps. Software developers and testers find process flows to be useful to provide context for a set of requirements. So this is very easy to translate into requirements. Process flows are also used to show KPIs, key performance indicators, metrics, either the baseline or target metrics. You know, on this diagram, you can define which are your key performances and which are the items or which are the interactions which are most important to you. They could be your KPIs. Each KPI is shown in brackets over the steps the metric applies to. This is useful when creating solutions to replace existing solutions where there is already a performance level threshold that needs to be maintained. Relationship to requirements, process flows are an easy model for deriving requirements. By consideration of the functionality or qualities needed to support each step of our business process. This is done during elicitation sessions or during analysis. When requirements are already specified, these can be traced back to the process flow steps to see if there are any requirements missing. Steps that do not have sufficient requirement map are requirements that are unnecessary. Requirements that do not support any steps in a process, they may be deleted later. Then are the use cases. Use case describes a set of scenarios. Scenario is any single pass through a system to achieve a goal for the primary actor. Like you see, I say if I want to order an old recipe, then what will happen? So this will be a one scenario, and a use case created will be created for that. If I order a new recipe, but the items have yet not be available in the store, what will happen? Or when I get to the store, that item is not shown there, is not exactly available at the place it was supposed to be, then what would be flow of that? So you can trace back those things, and these use cases will describe the various requirements in more further detail. Use case is a series of activities or actions and reactions that take the primary actor from initiation to the successful completion of the goal. Textual use cases are represented in a standardized document template or in tabular form with standardized columns. You can write it in form of a statement also, or it can be in a form of a table in which you can have rows or columns and shown each one of these use cases there. Use cases represent the functional aspects of a system or operation and as such are not used to document the non-functional aspects. So it will only define the functional.
Sir, we have already studied the use case. Then why we are again studying use case in process models?
Okay. Let me
see the use case which I requested you earlier that I'm good at it. So we skipped it.
That was use case diagram. Okay.
Okay.
Let me get to the list and I will tell you. You see here, use case diagram is one model and use case in journal is another model. So if there is any repetition, do let me know as if we can, correct that. And then comes the user stories and that is for agile. Let's move on to the user stories. You see, it is scope, use case is being used for scope models also, and it is being used for the process model also.
What is the difference?
This is a statement. This statement could be created there or here, both ways. When we are, okay, when you are trying to clarify the scope, you can create a use case and you can show it in form of a diagram. Here the use case is in form of a what you can say a statement or a table. So there's a difference between a diagram and a textual display of that.
Okay.
So use case is a different model. Use case diagram is a different model.
Okay. So can we hold for 2 minutes?
Okay, sure.
Please. Sure, please.
Okay. Can you see this example of use case?
Yes, sir. I can see.
So you see, this is descriptive in nature. This is not a diagram. And diagram, you can refer back and see to the previous slide in which the diagram.
Yes, sir. I know you. Yes, sir. It's an overstrip. It has an actor. It has a relationship.
Yes.
So, okay.
Now,
So in process models, we used to use use cases, and in the previous model we have a use case diagram. That's a
yes,
total
exactly.
different model. Okay.
Exactly.
Okay.
So this is the further description of that. This documents the whole thing.
Okay. Okay.
Okay. After use case,
Right.
we have got the user stories. As we very well understand user story also, a user story is a statement written from the point of view of the user and describe the functionality needed. And who collects the user stories? Basically, this is the product owner in an agile system. He collects the user stories, he elicits the information, and the Scrum team normally helps him create it into a backlog, helps him sort it out, sort those user stories out, and helps them build into a product backlog. Prioritized backlog also, and then refined backlog and all that. That story goes on and on. Typically, a user story is used in an adaptive methodology like agile development, but can be used in other methods also. A user story often takes the format of, this is the format, actor, function, and business reason. As an actor, I want to be able to function so that I can achieve certain results. You see, this is a very simple format of that, and that's how user stories are built. And then we have got actors also. Actors are also to be described, that there is a format for actor also. There is a discussion on that, how the actor can be explained. So we have to have certain role.
So this is an
Yes.
So this is an example of user story.
This
As
is
an actor, I want to be able to function.
This is a format. You replace the name of the actor. Say as a sales manager, I want to be able to sell more products so that I can increase the business revenue. You understand that?
So this is what you have said me is an example.
Is an example. Rather, I would say it is a format, and you can create an example out of it.
Okay, this is a syntax.
This is a syntax.
Okay.
Yes. This is a syntax. The function provides a small discrete piece of business value or function. The elements of the invest acronym can be applied to all requirements regardless of the format to ensure quality of the user stories. So how do you do that? There could be independent user stories. There could be negotiable. Each story should stand alone. This is independent. Avoiding the creation of
Sorry.
Yes.
All right. So in your latest presentation, the previous slide is not available. So I guess you have to once again upload your latest slides.
Please, previous slide. Which slide? Previous slide.
In which the syntax you have shown me.
This is
that
not available.
Syntax is not. Yes, sir. It's available.
You have downloaded it?
So,
okay.
Downloaded and I opened your presentation. So it's not available.
Okay, what I'll do is I will have to make more slides at the end. I'll update that, and the new file will be uploaded. Tomorrow we'll be able.
No worries, sir. Okay.
We'll fix this issue tomorrow, because they're so lengthy. There's every tax and everything. It takes a lot of time. Anyways. Okay. So we were talking about each story should stand alone. It should be independent. So we should not create dependency between the stories. And each story should be negotiable. It's subject to negotiation at all times regarding the content, priority, form, function of the story, and becomes more concrete just before implementation. So that means the story could be, very hazy in the beginning, and you can keep making corrections to that and improving it, but it should be negotiable, it should be changeable, and it should be, completely independent. The stories should be valuable. The story only defines feature or function that are valuable to the business and that help solve the business problem. Story should be estimable. You should be able to calculate how much effort can be put into it. It should be brief and small, and it could be tested. It could be verified. It could be easily tested or verified. And did I show the example? Okay. Again, that diagram is also missing. I should have had that. Okay. That diagram is here. It should have been earlier. Let me fix this. This diagram is for user stories. Yes, it is there. Okay, can you see this diagram?
Not yet.
Okay.
Yes, I can see user stories as a diagram. Epic. As a customer, I want to go to the store and easily buy ingredients needed for a recipe.
Now, this is an epic. The top line, this is an epic. Epic is a journal story. It is also a user story, but it's a very general story, as the stakeholder explains. So I have put it in his words. I say, is it all right if I say, as a customer, I want to go to the store and easily buy ingredients needed for this recipe? He said, okay. Then I break this story down into, or refine this story into user stories, and these three different steps come out of it. Number one, and each one of them is, independent. As a customer, I want to be able to find past recipes so I can prepare them again. As a customer, I want to select a store to purchase recipe ingredients so I can choose a store location. As a customer, I want to have a store map of where the recipe ingredients are so I don't have to hunt for them. You see, the epic has been broken down into user stories. So the basic requirement we collect, the product owner collects from the stakeholder or the customer, is in form of epic. Later on, product owner sits down with the Scrum team and they work together to break the epics into user stories as if they can be properly adjusted. They can be catered as requirements, and each user story will have certain acceptance criteria mentioned. That is the next step. The acceptance criteria is established once the user stories has been established. Like you see, the very first one, as a customer, I want to be able to find past recipes so I can prepare them. So what is the acceptance criteria? Customer should be able to search the past recipes, number one. Number two, search terms can be by recipe name, ingredient or date. A search can return 0 or 1 or many results. For one or many results, a user can choose a recipe from the list. So if you are a software developer, you would know how important these acceptance criteria are. The statement which was given in the user story is a generic statement. It has nothing to do with ID. But acceptance criteria, the person who is developing the application or who knows how to develop application would know he has to give a, pull down list, or he has to give a yes no field or whatever kind of. So this acceptance criteria will translate, this acceptance criteria will easily translate into your requirements. Similarly, you can see other acceptance criteria for other user stories. So the usage of the user story focus on what the user is looking to accomplish and are written from the user's perspective, what he wants. They can be derived from process flows when the mode is used. User stories are helpful on projects because they are easy models for business stakeholders to engage in creating. In agile methodologies, user stories populate a backlog. So we will keep collecting all these user stories and keep putting them in a box. And to put it more like it, if a user story is a piece of paper, then I keep putting all these pieces of papers one top of other and in a box, and that caters for all my requirements. Later on, I prioritize them, which is the most important feature. I will bring them up. So prioritizing them together later would give me a prioritized product backlog. First I create a product backlog, then I create a prioritized product backlog, and then after every scrum, I will reprioritize it according to what job has been done and what is left, and that would be called a regroomed or groomed prioritized product backlog. As user stories get closer to the top of the backlog, these should be elaborated using relevant modeling techniques. Now, the stories on top, they must be groomed, they must be explained further like we defined the acceptance criteria. Right? If you can, it is not possible that you can find out the acceptance criteria for all the user stories right in the beginning, because we are going for agile. So we are working scrum on scrum. So first of all, the in the first sprint, what we'll do is we'll pick 10 requirements, we'll groom those requirements. We will, the 10 requirements we have picked, the 10 user stories we have picked, they will become the sprint backlog. And the Scrum team would groom those backlog, establish the acceptance criteria and converting them into the specific features and all that. So it is their job. Acceptance criteria should be developed at this time. For additional information on creating acceptance criteria, solution evaluation, the next chapter, the sixth chapter, section 6 would address that. Relationship to the requirements. A user story contains many requirements. A single user story may have many requirements, as we have seen earlier also. Therefore, it serves as a functional grouping of requirements. Stories can be traced directly to the business objective to substantiate the value of requirement, and can also be traced to the elements in other models. User stories can be used to manage, prioritize, trace, and allocate functionality to releases and iterations. Although user stories are not detailed, they contain acceptance criteria and express user needs. Okay, I think I should close here, because then we start rule models, and naturally we can start from here tomorrow, and then we have got a lot to cover. Is it okay?
Yes, sir, I am comfortable. No worries.
Okay.
What I would request, kindly upload the updated presentation so
Okay.
that I can relate with my notes as well.
I'll do that.
The next thing, no problem, sir. You can do it as per your convenience. Number two, sir, is your that class is still happening till 5 p.m.?
Yeah.
PGMP class?
Yes. I've started the PBA class in the morning also. Business analysis class in the morning.
Oh wow! At what time?
9 to 5. Tomorrow we are starting.
So, okay, so tomorrow will be the first day, and it will be for 5 days.
It will be for 5 days. Yes.
And it's a physical class, not the online, right?
It is not online. Yes, it's not.
And can I ask you how many students are there?
Yes, not many students. There is, actually, this is specially arranged for a person who has come from Saudi. Took leave. He wanted first to do the PGMP course and then this PBA course. So I am specially doing it for him.
Okay, okay. So is he going to buy that Rita book? If we order one book, so can we share the cost of it? Is there any possibility?
I didn't understand. You want to buy a Rita book?
No, I'm just asking. That chap is interested to buy the Rita book. Did he talk to you about this?
Which one? A risk management book?
Sir, business analyst book.
Okay. No, I don't think he is interested because he is just learning these things for his job. He's not interested in certification.
Okay, okay, okay. Fine, sir, fine. All right, sir. So you are busy from 9 to 5, right?
Yeah, 9 to 5 and then 6 to 8 and then 11 to 1 at night.
So then what time PGMP classes you are taking?
Yeah.
At what time PGMP classes are in place? Basically from 9 to 5 you are taking.
PGMP is finished now. Today is last day. Tomorrow we'll just be concluding PGMP and starting PBA.
Okay, okay, okay. With that guy, okay,
Yeah.
fine. So by 5 and 6 to 8 it's my class, and then 11 to 1 which course you are taking?
That is PMP.
Yes, sir, sure.
Okay, take care. Thank you very much for joining and see you tomorrow. Thank you. Take care.
Inshallah, sir. Inshallah. Thank you. Allah Hafiz.